Welcome back to Outsmartable Educational Videos. We've been talking about right triangles and trigonometry. Let's pick it up from where we left off. Last time we talked about how to calculate the trig functions, 6 trig functions for an acute angle belonging to a right triangle. I gave you this little mnemonic to help you remember how to calculate those functions. And then we mentioned the fact that there are some special right triangles that have characteristics that you need to memorize. In particular, those right angles that have 30 and 60 degree acute angles, as well as isosceles right triangles that have two 45 degree angles. Should be able to derive this table from this definition, knowing the characteristics of those right triangles. Today we're looking at obtuse angles, and the focus of the presentation is on the unit circle. What is the unit circle? Well, the unit circle is a circle that has its center at 0, 0 and has a radius of 1, so that any line drawn from the center of the circle to a point on the circle has a length of 1. And what's the significance of that? Well, look at a 45 degree angle. Your 45 degree angle has a hypotenuse equal to 1. We drop down the perpendicular here. We know that the cosine of 45 degrees is equal to 1 over the square root of 2. So what that tells us is that the length from the center to this point right here, the x length of this right triangle, has to be 1 over the square root of 2, because this length divided by 1 has to be equal to 1 over the square root of 2. Same thing with the sine. The distance in the y direction of this right triangle has to be 1 over the square root of 2, because this side divided by the hypotenuse has to be equal to 1 over the square root of 2. So we have the coordinates of this point right here, where the 45 degree angle intersects the circle. Let's rotate, or let's reflect that angle on the y-axis, bring it over into the second quadrant. This gives us a 135 degree angle. But this angle also forms a 45 degree angle with the x-axis. Notice that the coordinates are identical for this point, except that now the x value is negative. The x lengths are the same, the heights of the triangles are the same, the coordinates are the same, except now the x coordinate is negative instead of positive. Reflect both of these angles over the x-axis. We get, again, an angle of 225 degrees, but it has a 45 degree angle with the x-axis. If we go all the way around to the x-axis again with an angle, well, let's stop here at 315 degrees. We still have 45 degrees to go to the x-axis, which tells us that our reference angles for 135, 225, and 315 are all 45 degrees. The way you calculate your reference angle for the second quadrant, you take the end line of that angle and calculate the distance to your x-axis. That's the reference angle for a second quadrant angle. For a third quadrant angle, calculate the distance from the angle to the x-axis, where your x-axis is 180 degrees. So take the angle minus 180. For the fourth quadrant, same thing. Distance from the angle to the x-axis, it'll be the 360 in this case, minus the dimension of the angle. This symmetry is true for all of these angles. Here's your 30 degree angle. We've reflected it over the y-axis, then reflected those two over the x-axis. For 30 degrees we have 150, 210, and 330 all have the same coordinates for the point on the circle where they intersect the circle, with the exception of the sine. If you're in to the left of the y-axis, your x coordinate's going to be negative. If you're to the right of the y-axis, your x-coordinates are going to be positive. Same thing with your y-coordinates. Above the x-axis, your y-coordinates are positive. Below the x-axis, they're negative. Here we've expanded that concept for the 30 degree, the 45, and the 60 degree angle reflected and reflected again. You need to memorize the values of the coordinates for all the points on this unit circle, remembering that the first coordinate is the cosine of that angle and the second one is the sine of that angle. Okay, with those ideas, let's try some problems here. Here's a right triangle. It wants us to find the angle A. Well, let's see, we have a smaller right triangle here, which is isosceles. So we know that both of these angles are 45 degrees. And we know that in a 30-degree right triangle, the remaining angle is 60 degrees. So the larger angle here is 60 degrees. 60 minus 45 is 15 degrees. How about this next one? Find the tangent of 150 degrees. Well, now we're finding the tangent of an obtuse angle. How do you do that? To find the trig function for an obtuse angle, first find the reference angle. This is the distance from the angle to the x-axis. It's always positive. It's always between 0 and 90 degrees. See, 150 degrees. 150 degrees, here it is. It's in the second quadrant, and the distance to the x-axis is 180 minus 150, so it's 30 degrees. So we found our reference angle. 2, find the trig function of the reference angle. Find the tangent of the reference angle. Well, let's see, tangent of 30 degrees is equal to the sine divided by the cosine of 1 over the square root of 3. And then 3, determine the sine based upon the quadrant the obtuse angle ends in. 150 degrees ends in quadrant 2, and in quadrant 2 the tangent is negative. So the answer here is negative 1 over the square root of 3. How about number 3? Find the length of side H. What do we know about this? Let's put what we know down and see if it leads us to a solution. We know that the sine is equal to 20 over h. Multiply both sides times h. Divide both sides by the sine of 50. That looks like our answer unless we know the sine of 50 degrees. How about number 4? Find the cosecant of b and the cotangent of b. Well, we know the sine of b. This looks like one of those 3, 4, 5 right triangles based on the Pythagorean theorem. So the sine of b is going to be 3 over 5. And the cosecant of b is the reciprocal of the sine, so it's going to be 5 over 3. How about the cotangent? We know the tangent of b is equal to 3/4. So the cotangent is the reciprocal of the tangent. That gives us 4/3. Back to an obtuse angle in number 5. Start by finding the reference angle for 225 degrees. Here's 225. How far is that from the x-axis? 225 minus 180 is 45 degrees. Find the sine of 45 degrees. So here's 45 degrees. The sine's 1 over square root of 2. Determine the sine based on where the angle ends. 225 is in the third quadrant. The sine in the third quadrant, let's see, that's going to be the opposite over, that's going to be, sine is negative in the third quadrant. So sine of 225 is negative 1 over the square root of 2. Okay, that's all I've got for you today. We need to work lots more problems, and we'll continue to do that in the videos to follow. Have a great day. Thanks.